surveyor. So let's get cracking. Yeah, most of you have joined us before. I'm Trevor Clements, Head of Business Development at Hertfordshire Building Control. My colleague on the controls, making sure I don't get heckled too much, is Rachel LeGood. Yeah, and another briefing. This leads on from the last one, which was about the Building Safety Bill and the Future Homes Standard. And what we said was we'll drill a bit more down into the new approved documents, particularly approved document L, that are coming from that from that effort. So I will be covering part L. The new approved document is the result of 2 consultations that ended in April 21. It's a stepping stone. It's an interim approved document, as I mentioned last time, towards the Future Homes Standard, which will come in 2025. And that in itself is another stepping stone towards the carbon zero ready homes that we hope to be building from 2050 and living in. So the aim of the interim document is to give an uplift for new homes to produce 31% less CO2 compared to those built to current standards. As I say, we're going to focus on new dwellings today. Maybe not buildings other than dwellings can be a future event when we've got the final documents. I say that because I had hoped, and we originally were promised, that we'd have those in the middle of the year, but the final approved documents aren't yet out, and I hear that they will be released sometime in December. So hopefully we're as accurate as we can be as to what we can expect. So that's what we'll be covering: changes to the approved document L, covering new dwellings and extension to dwellings. And then I'll briefly whip through the changes to approved document F and the new approved document, which covers overheating, although there won't be a lot more to say than we did at the last session. So that won't take too long. So just recapping, the Future Home Standard coming in 2025, towards net zero in 2050. This is a slide showing the implementation timeline. So next month we expect the uplift of current standards to result in amendments to the building regulations, with the new interim Doc L being published alongside document F, plus the overheating document as well. So a full technical specification for the Future Home Standard will be consulted on then in 2023, so that we can then expect another amended approved document L and another version of the standard assessment procedure, the SAP calculations that work with approved document L, being introduced, and the necessary legislation coming in to bring that in 2024, ahead of implementation in 2025. So at this point, there will be no, going forward, there will be no fossil fuel heating in the new zero carbon ready homes, and they will be emitting 75 to 80% less carbon than homes built to current standards. And by zero carbon ready, I mean no retrofit is needed. It's just they're waiting on the grid to clean up and convert to low carbon generation to be truly zero carbon. So here are the transitional arrangements in simple terms. Yeah, so the new approved document L standards will come into force in June 22, and there'll be a 12-month transition period from that time. So in other words, any applications received before this date must start work by June 23. And after that date, any new applications will be assessed under the new standards. And when I say starting work by that cutoff date, June 23, I mean that's individual dwellings must start. You can't, or blocks of flats, you can't just build one or put a foundation in for one house in a development of 100, for instance, and then expect the other 99 to get under the wire. The other 99 would have to comply unless they also get commenced before the bar comes down. So that's the transition. let's look at the summary of the main changes we can expect to see in the new approved document. It's now gone from 4 to 2 volumes, and volume 1 is the one we'll focus on, covering dwellings. There will be volume 2 covering non-dwellings. The latest version has gone with option 2 of the consultation, which was for a mix of fabric performance plus technology, i.e. encouraging the use of low carbon heating and renewables. So alongside that, there'll be a new version of the standard assessment procedure, SAP 10.1, and I think it will become 10.2 when it's introduced. And that's based on total energy performance, and I'll explain that a bit more later. And this will be the approved calculation tool for demonstrating compliance for new housing. So the notional dwelling on which the performance targets are met in the SAP have now, or will have, lower targets for air leakage. They'll have higher fabric efficiency standards and higher efficiency standards for controlled fittings. And there's an expectation that new technologies like wastewater heat recovery, more on that later, will be included in specifications. If they're not, there will have to be some sort of trade-off to compensate for that. Plus, there'll be more emphasis on provision of photovoltaic, I will say that clearly with my teeth in, panels in proportion to the floor area. And talking about photovoltaics, since the last SAP update, which some of you may remember was in 2012, energy generation has become much more green, and the average CO2 factor from the UK's electricity grid has actually halved. So this means that the carbon footprint of electric-based heating is going to be far more favourable. And who knows, we might even start to see panel heaters becoming an option again for some developments. Another thing to note is that on-site electricity generation, by that I mean things like photovoltaic systems and combined heat and power units, will have less impact on meeting the SAP targets. And the reason for that is because if we have greener electricity from the grid, it means that generating electricity on site isn't going to have the big impact it would have had in, say, 2012. So that there'll be an effect there if you are looking to improve SAP scores. Right, so for new dwellings, when we used to ask for calculations showing fabric efficiency and carbon emissions only, we're now looking at this total energy performance. So we'll be looking for the target CO2 emission rate, the TER, as we always have done, the target fabric energy efficiency rate, the TFEE. That's still there. There was a proposal to remove it in the earlier consultation, but there was pressure from responding individuals to keep that in, so it's retained. That is about considering things like the insulation values for the thermal elements, the air leakage rates, thermal bridging issues, solar gain, heating system efficiency, all those sort of things that are used to calculate the energy demand for space heating and cooling. But we've got this third new highlighted metric, which is the target primary energy rate, and that's an all new factor, which I will explain a bit more in detail later. So apart from that, we also need to see that the minimum base standards, i.e. the bottom line standards, have been met in the design for fabric efficiency in terms of U values of the thermal elements, and also minimum efficiency levels for the fixed building services. And this data is all going to be included in what's going to be called a BREL report, which stands for Building Regulations England Part L, apparently, as so I read. And that needs to be given by the applicant to the building owner and also to building control. And and they will be assisted in producing that by their energy specialist, energy assessor. And you'll see there that not only our specifications need to be included in that, but there's a need for photographs to be taken at key stages throughout the construction. So that's an all new thing, and it promises to create some challenges for building control. That's if it is retained in the final draft, which I anticipate it probably will be. And it says in the guidance that the photographs need to be taken at various stages in the construction, and it says photographic evidence of key stages during construction are needed that confirm the products identified in this BREL report are used in this dwelling and workmanship is of sufficient quality to support the calculated values claimed. And you need at least one image, one photo per detail as listed, and you see them all listed there. I won't go through them all because time doesn't permit, but you'll see it's all about cold bridging at junctions. It's about air leakage, or preventing air leakage, air tightness, should I say. Evidence of that the appropriate building services equipment are being used. And of course, these photographs also need to be given to the energy assessor, because he or she will need those to produce the as-built SAP calculation. So it's giving us a lot to wade through before we can issue the completion certificate. All you building control colleagues out there, probably like me, are thinking, right, how are we going to deal with this? You know, what level of scrutiny are we going to apply to make sure all these, we've got the photos we need and they show what they need. We need them to show us. You know, if we do spot any emissions and defects, that's not going to be very easy to rectify. You know, and if that's a stumbling block on a completion certificate, that's a whole can of worms being opened up. And as I've always said to our graduates when we're training them, and because I've got a particular bugbear about using photographs instead of proper site inspections, because a photo tells you what the photographer wants to show you. And I joke that, you know, that you can get images from you know, Google Images and use those to prove your building work meets compliance. Fortunately, the people who've put the regs together have thought of that, and it's noted that all these photographs have to have a geolocation attached to them, plus a time and date. So at least we know they were taken in the building in question at the time in question. So as I say, great deal of thought needed on that, on how we can sensibly and effectively apply this requirement. You know, the question is, do we simply rely on the professionalism of the energy consultant to assess the photographs in producing his final SAP calculation as built, and then we just take that on merit and accept it if he's a registered assessor? I'm not sure if that's a good enough way of dealing with it, but we will discuss in due course. I mentioned the bottom line for standards for new dwellings for energy efficiency. That's one of the 4 hoops that the designer has to jump through, in addition to the SAP targets. So you'll see there we've got now table 4.1, which gives the limiting U values in new dwellings. The bottom line, if you like. So you've obviously got to hit your targets, but in doing so, you can't fall below a certain level on your fabric efficiency. I've just shown in red the current minimum standards. So you'll see they're all generally been tweaked. Roofs being tweaked 0.16 from 0.2, etc., etc. Air permeability. Currently, it's 10 meters cubed per hour per meter squared at 50 pascals. It will be going to 8 as a minimum. There'll also be an option to test at a lower pressure of 4 pascals with a minimum leakage of 1.57 being the bottom line that you should be achieving. Obviously, these don't relate to extensions to dwellings. I'm going to tell you a bit more about that later on. This is all new dwelling stuff still. So right, a bit of a slide to wade through and hope I don't get lost. This is about the primary energy rating, this new metric. It's a system that's already been used widely in Europe, and now we're hooking into it. And I'll give you the definition of primary energy, which I think you might be able to see on the slide. It's energy from renewable and non-renewable sources, which has not undergone any conversion or transformation process. So give an example. Obviously there's chemical energy tied up in fossil fuels like coal, for instance. That's a source of primary energy. However, a unit of electricity that's created from burning that fossil fuel would not be considered primary energy because it's gone through that conversion process. Similarly, you've got natural gas. It has to be refined, it has to be transported, and that all uses energy. You know, heating oil is the same. And the SAP software will use primary energy factors and heating plant efficiency to convert the calculated energy requirements of a dwelling into a primary energy demand figure. So give you an example of what primary energy factors are. For gas, it's 1.13. So in other words, we need 1.13 kilowatts of energy to extract 1 kilowatt of gas from the earth, refine it, and then pump it through the UK's pipe network to reach the dwelling and the boiler. So that's 1.13. Surprisingly, electricity is currently a bit higher at 1.5. So 1.5 kilowatts to produce 1 kilowatt of electricity at the consumer unit. So I've given some examples just to try and embed in the idea of this. We've got two identical houses with the same heating demand, 10 megawatts, and different heating systems. So in other words, they're identical apart from the heating system. So we've got dwelling A first of all. As I say, it's a 10 megawatt heating demand. It's got a 90% efficient gas boiler, and as we mentioned, the primary energy factor for gas is 1.13. So the associated primary energy would be 10,000 kilowatts times 0.9, because it's 90% efficient, times the factor 1.13. So that gives you about 12.5 megawatts, as opposed to dwelling B. This dwelling has a electric heat pump, so that's going to be 300% efficient. Same heating demand, so the factor is primary energy factor for electricity being 1.5. Multiplying that out, we are then saying we're multiplying the 1.5 by the 10 megawatts divided by 3 for the 300% efficiency of the heating unit, and we're getting 5 megawatts, so less than half for the gas boiler. So clearly, yeah, it's everything's steering towards heat pumps in terms of hitting your marks. But it's, as we said all along, it's still not mandatory. The notional house actually uses a gas heating system, so it's not like it's mandatory to use electricity. Right, so yeah, the targets in the SAP, as they always have been, are based on a notional dwelling. So the target emission rates and all this are all a notional dwelling, and the standards have been changed from the 2013 version. As I just said, they're still based on a mains gas boiler. Few U value tweaks there. You'll see roofs have gone from 0.13 to 0.11. Doors have been tweaked from 1.4 to 1.2. We've got the air tightness still the same at 5 meters cubed. We've got a new one on the primary flow temperature that's assumed in the notional house. That's 55 degrees centigrade, so a low temperature flow, steering us towards underfloor heating, or dirty great big radiators to compensate for the lower temperature. You'll also see there highlighted there's a new factor of including wastewater heat recovery to all showers and showers over baths. So if you don't do that, then you'll have to do something to compensate. And also an increase in the assumed area of photovoltaic panels. So that's, yeah, 40% of ground floor area. So I thought I'd put a slide in there because I know when I first looked at this, I thought, what on earth, how do you extract heat from wastewater? Sounds a bit of a palaver, and crikey, are we getting so extreme that we're trying to squeeze this small amount of heat out of the building? But you know, these things actually are quite efficient, and the principle is that part of the waste pipe serving a shower tray, or it may be a bath with a fixed shower in it, will include a heat exchanger to take the heat from the wastewater flowing down the waste pipe, and then that heat is transferred into the cold supply, which will either go to the hot water tank, or maybe it will go to the fitting itself. So if it's an instantaneous heated shower, it might be heating the cold supply to that shower, hence saving energy that would otherwise need to be produced by the boiler or the heating device if it is instantaneous in the case of the shower. So there you go. There's a few pictures of how it's done, either with a sort of a channel type waste for a shower, or as a coil around the vertical waste pipe. Be interesting to see them put in, and the problems that they create. I expect there'll be a few cursing plumbers. Nothing new there. So that was all about new dwellings, and this is now a bit, because I'm sure a lot of you will be sitting here thinking, right, let's tell us about what's going to happen with alterations and extensions. Well, we had the old tables 1 and 2, and this is the new table 4.2 in the draft approved document, which is the U values for new elements in existing dwellings. So that will, in other words, for extensions that you're going to bolt onto those dwellings. And you'll see there, I've marked in red the current standards and how they're being tweaked. So currently roofs, depending on whether the installations at rafter or ceiling level, were 0.16 and 0.18. Well, it's all going to be 0.15 now. Walls going to 0.18, so quite a lump off there if it stays that in the final draft. Floors 0.18 from 0.22, and also improvements to windows and doors and things like that. So the wall one stuck out at me as being possibly a tricky one. Colleagues out in the audience might have some ideas on the best way to achieve that in a masonry build. You know, I can see that heading towards full fill phenolic foams and PIR insulation systems, you know, with quite wide without cavities, but with you know, quite wide big thicknesses of insulation to get that. Which, yeah, again, we had curtain plumbers, now we're going to have curtain bricklayers, because I know that stuff's a damn nuisance to put in, and to put in properly as well, so that the weather tightness of the wall is maintained. We will see when the dust settles. So I just also thought I'd mention that nothing new here. We've always covered or controlled, should I say, the renovation of thermal elements. If you renovate more than a certain area of an element, whether that's a floor, a roof, or a wall, it's controlled work, and you have to consider upgrading the thermal insulation standard of that element. And that's a surprise to some people, but building control people are aware of it. And they've put some diagrams in to try and clarify the rules without actually changing them, because there's also always been quite a lot of confusion about that. And the rule is that if you are renovating more than 50% of an individual element, be that a particular wall, at the face of a wall internally, or the face of an elevation externally, then that's classed as a thermal, the renovation of a thermal element that's controlled. Or if you're renovating more than 50% of the whole surface of the building, or the surface of the thermal elements, again, that's classed as a major renovation. And if you do either, then you've got to look to table 4.3 that you see on the slide, and you'll see that if the existing doesn't meet the threshold value, then you have to upgrade to the improved value that's shown in column B there. There are let-offs. It's only if it's technically feasible to do so and cost effective. So you might have to do a calculation on the payback you get over 15 years. And there's also relaxations if it's going to mean your floor area is reduced more than 5% by putting insulation on, so that you can come under those standards in column B on those grounds. The diagrams, I don't know if you'll agree, they're showing the total area of the element in question, i.e. in this case an elevation, an external elevation, and one wall in a room. And then the green is the area being renovated, so you can calculate percentage. But I just think it's a bit strange that they're showing that it's, in both cases, it's around, well, it's under 25%, isn't it? So that wouldn't be controlled. So you'd think they'd be showing it at more than that, more than 25%. But there you go. It's a little bit clearer, maybe. I shouldn't grumble. It's a minor issue. So here's a slide on heating systems and new rules. We've got a newly used phrase in the regs, which is self-regulating device. In other words, something that will automatically monitor the output of heating or cooling to individually control the temperature. And these will need to be provided in each room or zone, usually in each room, but if you've got an open plan set up, then it could be in the zone. People are putting those in anyway, aren't they? And certainly if you've got underfloor heating, you're going to control that in each room thermostatically. But it's just laying down the rule that it is now mandatory. So if you are, so that will apply in new buildings, of course, but if you are fitting a new system in a house or fully replacing a wet heating system, you also need to design for that 55 degrees C primary flow temperature. Just putting a new boiler in, that wouldn't matter, but if you're totally stripping out and putting new central heating in, you'd have to upgrade to that type of system. So totally calculate out your radiators again, and to do that, you'll see in the slide there's a BRE guidance document on designing low temperature heating systems, which is worth a look, quite a useful thing. We've also got new rules on sizing of systems, and particularly not oversizing systems. Obviously nobody wants to undersize them, or you can have a cold house, but also you don't want to make waste heat and make the system inefficient by oversizing it. And the rule is it mustn't be oversized by more than 120% of the design heating load. And there's a few publications that can give guidance on that, on how to size effectively. The one I would go to is that, as shown, the Energy Saving Trust's CE54, should I say, guidance document that I've shown in the slide, and that's freely available. More new rules, and more rules. Well, there's more rules on heat pumps, that they be designed and installed in accordance with the MCS standard, the Microgeneration Certification Scheme standard, MIS 3005, shown at the top. So that's something to look at. Cooling systems have to have an energy efficiency ratio of at least 4. And again, there's a size and requirement not to exceed 120% of design cooling load, so the counterpoint to the heating system requirement. And for mechanical ventilation, we now have new targets for fan power efficiency, and for a typical intermittent extract system that you're going to see in most houses, that's 0.5 watts per litre per second. That's the efficiency, the minimum efficiency level that we've got to aim for, that or better. Supply and extract package systems, so your mechanical ventilation heat recovery, must include heat recovery, and you need to have at least 73% efficiency on those systems. And there's a few new rules on fixed lighting, and the document refers to the CIBSE guide, which is the SLL lighting handbook. That's the go-to read for that. And the standard is 75 lumens per circuit watt for efficiency of lighting that will be adopted. Again, doesn't stop people buying whatever light bulbs they want. It's not like when a few years back when we said you can only use fittings of a certain, that will take a certain fitting, but it's that is the rule for new build on these fittings that you'll be putting in. And there's a few rules on automation and control systems, and on-site electricity generation, which I won't go into today. So for just closing off, for anybody who missed the last seminar, this is briefly what we're expecting from the new approved document F. Also, hopefully that will be produced next month. We're looking to see more detailed guidance on considering external pollution when you're designing for new buildings in built-up areas, very sensibly. Tighter controls on retrofit works, recognising how these can introduce air quality issues, so putting new highly sealed windows, taking away any infiltration that was occurring in the old windows. You need to compensate, otherwise you're going to mess up your air quality. How do you do that? Well, you make sure that they have trickle vents when previously they may not have been mandatory. They will be. We're told the guidance will be simpler and unambiguous. Brilliant. That will be good. As I said last time, if there ever was an example of how to overcomplicate what should be a simple document, approved document F was it, in my opinion. And as I said last time, and sorry to repeat myself, but I'm sceptical as to whether this will improve the generally poor standard of air quality in new homes. You can't take out the human element. If the human doesn't push the button, doesn't open the window, doesn't open the trickle ventilation, then air quality is poor and air quality is invisible, so they'll never know. So yeah, automation I think is the answer, and possibly that will come in the future. And also, as I mentioned earlier, we've got this new approved document, which I'm fascinated to see. It's going to try to design out energy hungry air conditioning systems. Yeah, an approved document covering overheating, and hopefully we'll run another CPD session to cover that if it's got any complexity to it. What we do know is it's going to have provisions for limiting unwanted solar gain, so you're putting a maximum on glazed areas. The figure that's come in the consultation is 21% of floor area as the maximum. Providing means to remove excess heat from indoors, so minimum opening areas, max glazing, minimum opening areas, and for that we're thinking it's going to be around 12% of floor area. There will be two methods: a simple method, i.e. a fixed set of design rules, or you can use a dynamic method that's described in CIBSE guidance, CIBSE TM59, if you want to look that document up. There's consideration to external noise and pollution, so that's cross-referencing to approved document F. There's consideration of the security of ground floor windows, so Part Q of the building regulations, it's got to correlate with that, hasn't it? So if a window needs to be open as part of the overheating mitigation strategy, it needs to also be secure as part of the security strategy under Part Q. We're expecting the rules for Greater London area to be more onerous. There's more of a problem there on overheating, apparently, and that may call for shading on south-facing elevations and things like that. And as with ventilation, there's going to be rules on making owners and occupiers aware of how to use the building effectively, and so a developer will have to pass on a home user guide in handing over the property. Right, so almost in conclusion, for those who are interested amongst you and have time, here's the recently published 195-page report on the government's strategy for heating buildings over the next decade. And the ambition apparently is to phase out the installation of natural gas boilers beyond 2035. And reading from the document, it says that much like the move to electric vehicles, the move to low carbon heating will be a gradual transition from niche product to mainstream consumer option. No one will be forced to remove their existing boilers. Heat pumps are already a predominant technology in some other countries and have high levels of customer satisfaction. However, work needs to be done to build UK supply chains and drive down costs. Yeah, I think, and also convince people that heat pumps are, are effective, efficient, particularly as a retrofit proposition. It goes on to say, meanwhile, we will continue to invest in hydrogen heating through the neighbourhood and village trials, and this will allow us to take strategic decisions on the role of hydrogen in heating by 2026. So that's really is going to be interesting from the techie nerds amongst you like me, to see if hydrogen will be an option. It's clearly still very much on the table. It's a developing technology, and with this ongoing research, that's going to influence to what extent we see it as a viable fuel and incorporated into building regulations. So yeah, watch this space on that. If we can start to produce hydrogen without having to use a lot of energy to create it, that primary energy we were talking about, then maybe we will get some use out of our gas pipework network after 2035. We will see. Watch this space. So that's it. Sorry, I whittled on a long while there, but thanks for your patience. I don't know if there are any questions. Rachel?
Yeah, there are some questions. So we've got,
right.
We've just got 5 questions in the Q&A there.
Righto.
And we've got a couple in the chat. Do you want to go through the Q&A ones first?
Yeah, let's give it a go.
So the first one is roof light U value has increased.
Yeah, I noticed that. I didn't get that either. It's gone up to 2.
Mark also said as a maximum U value for roof lights really going up.
Yeah, that's what it says. I'm not sure why. Can't answer the question because I raised an eyebrow at that myself, but that's what was in the document. So there's clearly some sort of thing behind that. Whether it's hard to produce it's not hard to produce a highly efficient roof light. Velux do it all the time. So not sorry, no answer to that.
Is the BREL same as PHPP used for passive house?
Is the BREL same?
PHPP, is it the same as PHPP used for passive house?
I don't think it is. No, I think it's a separate entity. Is the answer to that? Yeah, I think it's a separate thing. It's specific. It's not specific to passive house. Passive house is a different standard, which is totally focused on fabric efficiency and mechanical ventilation. So this is a different animal.
Okay, one from Susanna. Hi Trevor, is there an obligation to have existing wall U value measured in advance of works as part of the architect plans in order to know what the gap is to get at the new wall U value level?
Blimey, Susanna, what are you doing to me? I don't get that. What
If you
can
click,
measure the existing U value of a wall in an existing house to I'm not sure why you
is there an
need to do that.
obligation to have the existing U value measured in advance of the works as part of your architect plans?
No, I don't think so. The only reason you might need to do that is if you're renovating a thermal element, you might need to know what the base value is. So whether you need to upgrade insulation to it, but you know, an extension is going to be treated in its own right. So the existing building wouldn't necessarily be upgraded. It's only when you upgrade really big buildings, I think over 1,000 square meters under the current regs, you need to consider upgrading if you extend the existing building. But so I think that's a no. And if I'm proved wrong, we will, as we always do, we will write around to all the delegates and let them know.
Okay, okay, one from Julian. If you have a block of flats being built at the transition time, does the commencement of work start as soon as the ground floor excavations are pulled, even if the stories and individual units above do not get constructed for some time thereafter?
Yes, Julian, I believe they do. Good question. Yeah, if you've got a foundation in the ground for a block of flats, that's a start. You take as long as you like to build those flats. You will do it under the old regs if you do it before the deadline date.
Another one, are air-to-air heat pumps covered anywhere? It's from Richard Merritt.
Are they covered? Well, yeah, they're an option. And there's the guidance document I mentioned is one that you should look to in terms of minimum efficiency levels and things like that. You know, the where was it? It was back in the slide, wasn't it? Yeah, there it is. The MCS guidance, MIS 3005. So that will be the minimum standard for heat pumps, whether they be air to air, air to ground, or air to water even. Or should I say ground to water, air to water, or water to water. That's probably a better way to put it, isn't it? There you go. So that's that. Okay,
and the final couple from Mark Rose. He says, can you confirm if improvements in energy efficiency will be required for retained thermal elements?
Yeah, hi, Mark. Nice to hear from you, a former colleague. So retained thermal elements, that relates to when you have a change of use of a building. And yes, the U values of those are also tweaked along with, you know, the values for extensions and alterations. So yeah, you'd have to look at the new table there where you do a change of use and upgrade as necessary if it is technically and economically viable. Of course, there's always those criteria, and also if it's change of use on a heritage building, then we have to take into consideration that factor.
And he also says, are there any recommended reading or resources in respect of primary energy?
Oh, right, yeah, you've got an interest in that. There's loads of it. Yeah, just if you Google that, there's lots of very interesting articles on that, going into some depth. Yeah, it's something that's been used a lot in Europe as a metric for regulations and energy efficiency, and we're now hooking onto it. So yeah, I can't think of anything specific, but I read quite a few publications on the internet that were readily available.
Okay, and last question from Simon Cope. I understand that the wastewater recovery system from showers requires a flow rate greater than that allowed by water efficiency calculation. Wow. So it may not be as efficient. What takes priority?
How interesting. That's a good question. And I didn't know that, as you can see by my surprised face. Yeah, we're all over maximum water usage per person per day, aren't we? Was it 128 litres or something? But yeah, if we're insisting on a shower being put in that can't actually work in conjunction with wastewater heat systems, then that is one we will have to answer. Thank you for pointing that out. We'll research that and get back to you. Interesting. There's always one that will catch me out, and today probably more than one. But there you go. Like I say, we're just a humble building control surveyor. We're masters of all trades in building control, and we're not absolute expert in everything, as you can tell.
That's it for the questions. All done.
Fine, right. Well, that's good. Nothing too painful. I hope everybody enjoyed it. Next session then, we're going to have a break over December. We're going to go next with one in January 22. And my good friend and colleague, resident guru in the building control, Les Ryder. Les is, as some of you may know, is our major projects manager. He's back to take you through a presentation on sprinklers and mist systems, and I've seen it. It's really good. It covers the key differences, the regulations involved in them, the design principles. Because there's a lot of fundamental misunderstanding about the key differences on the methods by which they are used in fire safety strategies. So Les will be doing that in January. And then we'll have another menu set up for you following that.
Okay, and I'll be sending out my usual post-event email after this event with a link onto the video. And if anybody needs a CPD certificate, once they've got their email, they can email me back, and I'll produce a certificate for you.
Excellent. Well, thank you, Rachel. It only remains then for me to wish you a happy festive season. A time to eat, drink and be merry, and briefly forget about things like primary energy factors and wastewater heat recovery systems and flow rates of showers. And in fact, let's all try and forget that we actually have to work for a living just for a few days, and then get back to it in 2022 when we can get back to saving the planet. So all the best to you, seriously, from Hertfordshire Building Control. I hope that was enjoyable, and look forward to seeing you soon after you having a very enjoyable break.
Okay,
bye for now.
Thanks.
See you soon.
Bye.